Hi all, I hope you guys are fine and safe. So I know that we have not completed gravitation yet, but gravitation is actually part of physics, and I thought that this second chapter, periodic classification of elements. So this second chapter, periodic classification of elements, is a topic which has more theories than any particular concepts. Yeah, we do have concepts in this chapter, but yeah, for that you might not need a chalk and a person to explain. So let us start with the chapter second, periodic classification of elements. So the first paragraph is about classification of elements. So here they have already mentioned that in the previous standard you have learned that all the atoms of an element are of only one type. Today 118 elements are known to the scientific world. It means that scientists till now have discovered only 118 elements. However, around year 1800 only, about 30 elements were known. So when it was 1800, we knew only 30 elements, and yeah, when like in 200 years we reached to 118 elements. So more number of elements were discovered in the course of time. More and more information about the properties of this element was gathered. To ease the study of now, if you are having 118 elements, you might need a simpler way to study all these elements, right? You cannot just write it in a notebook or write it someplace. There must be a simple way for students like you to understand all these elements. So scientists for that started studying the pattern if they can find any. They started looking for their properties and they wanted to classify them in categories to make you understand in some simple terms. Now you know that in the initial classification elements were classified into the groups of metals and non-metals. So the author, the writer of this textbook is trying to say that at the initial time when the elements started getting classified, they were simply classified into two groups, metals and non-metals. Later on, another class of elements called metalloids was noticed. So first metal and non-metals came, and then later on metalloids came. As the knowledge about elements and their properties went on increasing, different scientists started trying out different methods of classification. So yeah, it is true, right? Like every person has their own idea, and with their unique idea, they try to make things simple. So the first scientist who tried this was Doberinus. He was a German scientist, and in 1817 he suggested, like he proposed a theory, he created a theory that properties of elements are related to their atomic masses. Now what are properties of element? Like we have properties of human beings. They belong to some caste, they belong to some race, they have some skin color, right? They have some accent. So these things are called properties. Now for elements also we have properties. Some of the elements are shiny in nature and some of the elements do not shine. Okay, so let us go further. He said he made groups of 3 elements each having similar chemical properties. Now the author is trying to talk about chemical properties. Now physical properties is much more relevant to your appearance, but chemical properties is like as an example we can say that chemical properties is like how fast a mind, like someone thinks, or what kind of thought they are having, either positive or negative. Physical appearance can be like the person is fat or tall or short. So for elements also we have these chemical and physical properties. Physical properties is mostly responsible for appearance of the metal or non-metal or the elements, and chemical properties means like how they behave when they are put in a reaction. Now you might not know what is a reaction. Do not worry about it. Reaction means basically we will try to add some two compounds, two elements, and then we will try to find some third product. We have a separate chapter for that. So chemical properties are generally derived from the chemical reaction, and then he made a group of three elements each. So he took three elements, and those three elements were having similar chemical properties, and then he called them triads. He arranged the three elements in a triad in an increasing order of atomic masses and showed that the atomic mass of the middle element was approximately equal to the mean of atomic mass of the other two elements. Now, this sentence might look complicated, but trust me, it is not. It is very simple. I will tell you how. Pay attention. So, yeah, the Doberener suggested, like he made this group of three elements, and then this group of three elements, and similarly this group of three elements. Now, if you are not familiar with the symbol of this element and what they are called, no problem. I will take you all through it. Let us let us assume now that this is lithium, sodium, and potassium. They are actually lithium, sodium, and potassium. But yeah, now try not to get confused with the symbols. Just understand what is happening. So what Doberener suggested, Doberener said that if I'm having three elements in a triad and everything has a mass, right? Every object has a mass in the world. So similarly, even the element have mass. That mass might be too small, but they do have the mass. So for atom, every element has an atom, and their atom has a mass. So what Doberener suggested was, if the mass of lithium is 6.9, and let's say the mass of potassium is 39.1, yeah, they have not actually mentioned here. So he said that the middle element, which is sodium, is equal to mass of lithium, which is 6.9, plus mass of potassium, which is 39.1, divided by 2, which is equal to 23.0. And then this was what he calculated. And then when he actually calculated the mass, atomic mass of sodium, he found out that it was 23. So he understood that, okay, the center, the one at the middle, here it is bromine, here it is strontium, and here it is sodium. So if you want to find the atomic mass of the middle element in a triad, you simply have to add these two masses of the first and third, element first, and then element third, add these two and divide by 2. You will get the mass of the middle element. Now let us read this. Now you will understand. He arranged the three elements in a triad in an increasing order of atomic masses. So this you should not forget, that here their atomic masses are increasing. Like he has arranged as chlorine, then bromine, and then iodine. It means that in all three of them, iodine is having larger mass and chlorine will have smallest mass. Now let us read it again. He arranged the three elements in a triad in an increasing order of atomic mass and showed that the atomic mass of the middle element, now which is my middle element here? Sodium. Which one is here? Bromine, sorry. Yeah. So it was approximately equal to the mean. Now they are using the term mean because in mathematics they have defined mean something like this. Number of elements you are adding divided by, elements you have to basically, mean means average, finding out the average. So we usually find out the average of two elements by dividing it by 2. So they have added the mass of the first element and the third element and divided it by 2 and found the mass of the middle element. So it was simple. Atomic mass of the middle element was equal to the mean of the atomic mass of the other two elements. Yeah, okay, fine. You understood Doverinus right? However, now there is some problem. Let us see that. However, all the known elements could not be classified into Doverinus triad. So not all the elements were able to classify like this: lithium, sodium and potassium, calcium, strontium and barium, chlorine, bromine and iodine. These three were following this triad, but there were other elements too who were not following similar properties. So yeah, it is basically one of the drawback. Drawback means reason of failure for Doverinus triad. Now, if the question is identify a Doverinus triad, you can simply add the first and third, divide by 2 and check if it is equal to the center one. If it is not, it means that the element is not a part of Doverinus triad. And if it is equal to the center one, it means that the triad is actually a Doverinus triad. So second scientist came, Newland's law of octaves, the English scientist John Newland. He correlated the atomic mass of element to their properties in a different way. Now he tried something different. In the year 1860, now who cares about the year? But yeah, fine, let us hear it. Newland arranged the elements known at that time in an increasing order of atomic masses. So again he took all the elements which he had and arranged them in an increasing order. Then it started with the lightest element, hydrogen, and ended up with thorium. So you can see hydrogen is here, right? So yeah, okay. Then lithium. If you don't know the name, it is completely fine. Just listen to what I am saying. Beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. So yeah, so he actually arranges element in the increasing order of atomic masses, and it is saying that it started with the lightest element. Now this is the part where you can get the fill up. Lightest element, hydrogen. So you must know this. So lightest element is the hydrogen, and then ended up with thorium. He found that every eighth element had properties similar to those of the first. Now what he did was, okay, hydrogens, like the next greater one to the hydrogen is lithium, and the next which is directly like closest one to the lithium and greater than it is beryllium, then boron. Basically you can put this symbol here that hydrogen is less than lithium, lithium less than beryllium, beryllium less than boron, boron less than carbon, carbon less than nitrogen, nitrogen less than oxygen. So he found that every eighth element had properties similar to those of the first. So one element, second, third, fourth, fifth, sixth, seventh. What he found that the eighth element was having properties similar to the first, and then after again 15th element was having properties similar to the eighth. So like it was like 7 sequence, and then the properties were getting repeated. So for example, sodium is the eighth element from lithium. Where is sodium? Sodium is Na. Yeah. So from lithium, sodium is the eighth element, right? First, second, third, fourth, fifth, sixth and seventh. Yeah. Like if you start from lithium, you will get eighth here. So this is the eighth element from lithium, and both have similar properties. So also magnesium shows similar property to beryllium, and chlorine also, chlorine we can see here, shows similarity with fluorine. Okay, so Newland compared this similarity with the octaves in music. Now let us come to this part. In the Indian music system, there are 7 mainly notes, and they are sa re ga ma pa dha ni, and their collection is called saptak. The frequency of the note goes on increasing from sa to ni. Then comes the sa of the upper saptak and the double frequency of the, okay, useless, no need. I thought there must be something meaningful, but not today. But yeah, you can, what you must understand is Newland compared the similarity with the octaves in music. like we have this octave in music called saregama. So he compared them like this, and he called the similarity observed in the eighth and first element as law of octaves, because every first and eighth element, every second and then like the eighth element after the second one. So yeah, all the elements that were apart from like that were having eight gap between them were having similar properties. So he called the similarity observed in the eighth and first element as the law of octaves. So these were the elements that were found till 1866. In 1866 we had these elements known to the world. Now there were many limitations. Limitation means constraint. So what were they? The law was found to be applicable only up to calcium. Now this one also has some drawback. This law which he made was only applicable till the calcium, because after calcium this law was found okay. Newland fitted all the known elements in a table of 7 by 8, that is 56 boxes. Obviously we are having Newland placed 2 elements each in some boxes to accommodate all the known elements in the table. For example, cobalt and nickel, cesium and lanthanum, I think, yeah. So Ce and La, where is Ce and La? Yeah, here. So this were like if I am giving one element to every box, so just to fit the known elements till that time, he was giving 2 elements in one box, which was actually a little unfair. So like not many of people agreed with this law. Now let us read the examples. So he placed some elements with different properties under the same note in the octave. So yeah, so even if they were having the octave, he placed some element which were not having similar properties. For example, cobalt and nickel. Let us come here. Cobalt and nickel, right? So they it is saying under the note do along with the halogens, while Fe having similarity with cobalt and nickel away from them. So he wants to, like the author wants to say that Fe was having property similar to cobalt and nickel, but they are not 8 distance away from each other, right? This is Fe and the second one is cobalt and nickel. So the author want to say that Fe and cobalt nickel should come in one column. This is column, and this is row. Horizontal ones are rows. So the author wanted to say that if iron and cobalt and nickel are having similar properties, why are they not in one column? And then also Newland octaves did not have provision to accommodate the newly discovered element. So yeah, till that time scientists knew that there are many more elements which are not discovered, but Newland, he just created the table with the known elements only. He did not leave any space for the future elements which will be discovered later on. So yeah, now let us read about this. The properties of new element discovered later on did not fit in the Newland's law of octaves. So yeah, he created a law and he built it, and yeah, he find it interesting till calcium. After calcium, the rules were not followed, and the new elements that were found in the nature were not able to fit in the Newland's law of octaves. Okay. Then Mendeleev, one Russian scientist, Dmitry Mendeleev, he developed the periodic table of element during the period 3 years. Yeah, he wasted, like not wasted, I should not say. He actually took 3 years to develop Mendeleev's periodic table. And it is said by the scientist that it is the most important step in the classification of elements, because till now no one classified the elements properly. So now let us read about it. Mendeleev considered the fundamental property of elements, namely the atomic mass, as a standard, and arranged 63 elements known at that time in an increasing order of their atomic masses. So it is saying that Mendeleev thought that the fundamental property of element, fundamental means the most important property of element, the atomic mass. So he said that atomic mass is a very important property of element, and he considered this as standard, like some important attribute. And then he arranged this. Till then 63 elements were known, so he arranged all the 63 elements in an increasing order of their atomic masses. Increasing order means the smaller and then bigger and the bigger one and the bigger one. Yeah. Then he transformed this into periodic table of elements in accordance with the physical and chemical properties of this element. And then he later transformed this table or periodic table of elements in accordance with the physical and chemical properties of this element. We will read about it in further. Statement is not enough to explain. So Mendeleev organized the periodic table on the basis of the chemical and physical properties. I already told you what are chemical and physical properties. And these were the molecular formula of hydrides and oxides. So hydrides means when a metal, when an element combines with hydrogen to form some molecule, it is hydride. And when an element combines with oxygen to form some molecule, it is called oxide. Do not worry with the names. We will have it in detail later. Like we have the chapter called reaction. In that we will learn about it. And then the elements had some melting points. It means the temperature at which they melt. Then they had some boiling point. It means that the temperature when they boil. And then densities. Density is equal to mass upon volume. I hope you know that. Yeah. And then hydrides and oxides. So hydrides means the molecules that they are forming after combining with hydrogen, and molecule the elements will be forming when they combine with oxygen. So that if they are combining with oxygen, it is called oxide. Now Mendeleev found that the element with similar physical and chemical properties repeat after a definite interval. So he wasn't confirmed like what is the interval, but he found that the elements are having physical and chemical properties similar, and these all elements are repeated, like there is a fixed interval, and after that these elements are having similar properties. So on the basis of this finding, like whatever the Mendeleev found till now, Mendeleev created one periodic law, and he said that properties of element are periodic function of their atomic masses. Now here they like Mendeleev is much more concerned about mass. You should understand that a mass is, every object has a mass, and when you have to understand what is mass. If you don't know, you should Google it. Learn it, because this is very basic concept. So the vertical column in Mendeleev's periodic table are called groups. These all are vertical column. So he has named it groups, and the horizontal one he named it as period. So if you will see properly, Mendeleev's periodic table had 8 group, and how many? 12. He had 12 periods and 8 group. If you will see here, group 1, group 2, group 3, and then 12 periods. So now he has written here about the atomic mass. Hydrogen, the atomic mass of hydrogen is 1, and that is the lightest of, we just studied there, right? The element with the least atomic mass is actually hydrogen. And then he arranged lithium, beryllium, boron, carbon. These all are the atomic masses. Nitrogen has 14, and then oxygen has 16. Okay, now if you will see, he also tried to insert 4 elements at one single place. So we can understand that okay, this also won't last long, because इसने भी इधर गड़बड़ी तो किया. So the general molecular formula of compound, you do not worry about this. You will get confused. You will understand it once you read the chapter chemical reaction. You can read about scientist Dmitry Mendeleev if you have time. If you don't have time, you can simply skip it like I did just now. So there are some vacant places in Mendeleev's periodic table. Okay, is it so? Let us go back. These are vacant spaces, right? So Mendeleev was not dumb. He was very smart. He knew that these places, elements are not discovered till now for these places. But he had an idea that in future, one day, someone will discover these elements. So in some of these places, the atomic masses are seen to be predicted. He does not only leave the spaces blank, but he also predicted the atomic mass. Can you see? 68, 72, and 44. Like the element was not discovered, but he was able to predict the atomic mass. It means that is a great achievement. So yeah, due to uncertainty in the names of some elements, a question mark is indicated before the symbol in Mendeleev's periodic table. What are such symbols? Okay, let us go back. Where is the question mark? Yeah, here. So you can Google about this because you have to basically think about it. I'm not going to tell you this. But let us understand about merits. Now this is the first periodic table, I think, which had some merits, because we had no merits about Dobereiner and Newland. Now science is progressive. Okay, we know that. There is a freedom in science to revise the old inferences by using more advanced means and method of doing experiments. This characteristic of science are clearly seen in Mendeleev's periodic table. While applying the law that the properties of element are periodic function of their atomic masses. This is a very important line. You should probably mark it, because when it comes to Mendeleev, for Mendeleev, properties of elements are a periodic function of their atomic masses. But in future it won't be true. Yeah, the bitter truth is it won't be true. It will change. But till Mendeleev, this was the fundamental. Now Mendeleev arranged the element with a thought that the information available till then was not final, but it could change. So yeah, Mendeleev had this idea that whatever I am predicting is not final and it might change with time. As a result of this, Mendeleev's periodic table demonstrates the following merits. Now let us learn about the merits of Mendeleev periodic table. Atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, previously atomic masses of beryllium was 14.09, and then it was changed to correct value 9.4, and beryllium was placed before boron. Let us find beryllium. Beryllium, where is beryllium? Be is actually beryllium. Okay. Yeah, here we have beryllium and here we have boron. So yeah, it is saying that with the help, because of Mendeleev periodic table, we were able to predict the correct atomic mass of some elements, and which actually helped us to understand it better. Then Mendeleev kept vacant place in periodic table for elements not discovered till then. 3 of these unknown elements were given the names. He does not only leave the vacant place, he also gave a name: Ika boron, Ika aluminum, and Ika silicon. Yeah, these were the names that were given from the known neighbors and their atomic masses. And not just he gave the name, he also predicted the atomic masses of these elements respectively. Not only this, but their properties were also predicted. Later on these elements were discovered, and okay, so it is true actually. Later on these elements were discovered and they were named scandium, gallium, and germanium. Now this is important that you know that Ika boron was scandium, Ika aluminum was gallium, and Ika silicon was germanium, and their atomic masses was 44 for scandium, 68 for gallium, and 72 for germanium. The properties of this element matched well with those predicted by Mendeleev. So yeah, so later on they discovered and they were very happy that okay, we have an empty place, we will fix it there. And yeah, okay, so there are some properties about Ika, aluminum, and gallium. So he predicted this one, and this is the actual. So if you see, it is very much accurate. He predicted 68, it came 69.7. He predicted 9.4 density, now it is 5.94. Yeah, very close. He said that the melting point will be low, and yeah, 30.2 was the melting point, which is actually low. And then these things you might don't try to understand now, you will get confused. Yeah. So now there was no place reserved for noble gases. Now you might not know what noble gases are, but we will come to know about it slowly. But let us just understand that okay, we don't know about noble gases till then, and that is why I did not create any place for them or any empty place for them. But later on we started get the noble gases such as helium, neon and argon. They started getting discovered at the end of 19th century. So yeah, Mendeleev then created the zero group without disturbing the original periodic table, in which the noble gases were fitted very well. Let's go back to Mendeleev's periodic table. Yeah, let us try to find zero group. It is not here, right? So that's why they are saying that later on he has created this zero group in which the noble gases fitted very well. Now there are some demerits also. Obviously there would be some demerits. So the whole number atomic mass of element cobalt and nickel is same. Therefore there was an ambiguity regarding their sequence in Mendeleev's periodic table. Now, as it was said that what did Mendeleev say, that the atomic masses are the fundamental property, right? Now here cobalt and nickel were having same atomic mass. So how can you arrange the sequence in the increasing order if these two things are having same value? So that was an ambiguity, means a confusion. And then isotopes were getting discovered long time after Mendeleev put forth the periodic table. Isotopes means they have same chemical properties, but they will be having different atomic masses. So as he classified these elements on the basis of atomic masses, people were confused whether they should create like if the element is same and just having different atomic masses, whether they should create a new place for it in the table. And that was the challenge that they faced. And then when elements were arranged in an increasing order of atomic masses, the rise in the atomic mass does not appear to be uniform. Now you must understand this. Increasing order he arranged, right? He said that I will arrange this in increasing order. But it means that atomic mass should increase with respect to the position, but the atomic mass increase was not uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. So yeah, so since the rise was not constant, it was very hard to like predict how many elements can be discovered between the two other elements. Now position of hydrogen. Now hydrogen has some issue. Let us talk about it. Hydrogen shows similarity with halogens. Yeah, okay. Hydrogen was in group 1, I think. Let's go back and see. Yeah, hydrogen is in group 1, right? But it was showing the property of 7th group. So this was actually an issue, because you would like, how can you stay in one group, first group? You will stay in group 1 because you are having the smallest atomic mass. But then you are showing the property of halogens, group 7. So there was an issue regarding this. So yeah, for example, the molecular formula. Now molecular formula means when these atoms exist in the form of molecule, they are more stable. So the molecular formula for hydrogen is 2 hydrogen, H2, while the molecular formula for fluorine and chlorine are F2 and Cl2 respectively. In the same way, there is similarity in the chemical properties of hydrogen and alkali metals. Now, if you don't know alkali metals, it is completely fine. Just for now, you understand that alkali metals are the group 1 metals. So, the chemical properties was actually matching with the group 1. But then the molecular formula and other things were matching with group 7. So, people were confused about hydrogen. There is a similarity in the molecular formula of the compounds of hydrogen alkali metals. Now these are group 1 metals. That is why they have called them hydrogen alkali metals. Important point. Formed with chlorine and oxygen, on considering the above properties, it cannot be decided whether the current position of hydrogen is in group 1, which is called group of alkali metals, or group 7, which is called group of halogens. Okay, fine. So we understood the demerits of Mendeleev's periodic law 2. So that's it for this lecture of periodic classification of elements. I will discuss about modern periodic law in the part 2. Before that, you must try to solve the questions that belong to any topics such as Newland's law of octaves or Dobrynin's triads or even Mendeleev's periodic table. Try to solve them, even if they are one word questions like fill-ups or true and false, or if they are answers in brief. So yeah, please try to solve them, and the next video that I might upload would belong to modern periodic law. Be ready for it. Thank you guys. Please solve the questions because it will help you to understand.